Okay, here's the problem. A 5-foot woman walks at 8 feet per second towards a street light that is 20 feet above the ground. What is the rate of change of the length of her shadow when she is 15 feet from the street light? And at what rate is the tip of her shadow moving? So the first step in this problem is to draw a picture. So here's the picture. So here's the street light. It's 20 feet above the ground, like the problem said. Here's the lady. She's 5 feet tall. And the street light has a light here, and it's casting light down onto her, and then there's the shadow back here. So on the x-axis, we're going to call this x, and that's the distance between the lady and the street light. And s here is the size of her shadow, the length of her shadow. Alright, so what we are given in this problem is the 20 feet, the 5 feet, and also the rate of change of dx. dx dt equals negative 8 feet per second. Right, because she's moving towards the light, so it's negative 8 feet per second. Alright, and what we need to find is ds dt when x equals 15. And we also need to find what the tip of her shadow is, what the rate is on that. So we're going to call this whole thing here y. So that will give us the rate of change on the tip of the shadow. So we also need dy dt when x equals 15. Okay, so this is a problem involving similar triangles. So we know that this distance is proportional to this, and this is proportional to this. So we write it as s over s plus x. So this over the total of that equals 5 over 20. This piece over the total here. And then you rearrange, you cross multiply, you get 20s equals 5s plus 5x. Then you subtract the 5s on both sides, so you get 15s equals 5x. So then we can isolate s because that's what we need to solve for. S equals 5x over 15 equals 1/3 x. Okay, so now we need to find ds dt. So s equals 1/3 x, right? When we differentiate on both sides, we get ds dt equals 1/3 dx dt. And what they gave us, what dx dt is, it's negative 8. So ds dt equals 1/3 times negative 8. So ds dt equals negative 8 over 3. So that's 8 over 3, and the units here are feet per second, because that was the unit of dx. Alright, so ds dt is negative 8/3 feet per second. So we have that solved. Now we need to find dy dt. So dy, let's see, y equals x plus s, right? That's just from the picture. So if we differentiate here, we get dy dt equals dx dt plus ds dt. Now we just found that ds dt is negative 8/3 feet per second. So we can plug that in. So it's negative 8/3. And then dx they gave us is negative 8. So it's negative 8 dy dt equals negative 8 feet per second minus 8/3 feet per second. So if you simplify that, you get dy dt equals negative 24/3, right? Lowest common denominator. Minus 8/3 dy dt equals negative 32/3. And that is the answer. So the tip of the shadow is decreasing by 32/3 feet per second. So that is the answer.